Hi, everybody, and welcome to another edition of Space Club Career Chats. It is brought to you by New Worlds Await You, a program in partnership with NASA. My name is Natasha Wilkerson. I'm part of your Space Club Mission Control, and I am thrilled for this week's guest. Her name is Dr. Kelly Miller. She is a research scientist at Southwest Research Institute, a facility in San Antonio, Texas. She's in the field of space sciences. She's going to share some of the amazing work that she does. I'm so excited. Let's get started.
And Dr. Miller, how are you doing?
Hi, I'm great, thanks. How are you?
I'm doing well. And so I did leave one more riddle if you would like a chance to answer. So before I get to your presentation, so Aspen, you can help her out. Okay. What happens when you bring meat into space?
Meat into space.
Weird one, right? We're going to take that as I have no idea.
I'm trying to think that it orbits. It probably doesn't rot. I don't know. What happens when you bring meat into space?
You're thinking too hard. So it gets meteor.
Hey.
Right?
That's good.
Yeah, I liked it.
I think I think too much into it.
Yeah, y'all are too technical. Okay, well, you guys who are sending in those riddles, keep them coming because we're having a lot of fun stumping all of our guests. So I'm going to share my screen. Kelly, the floor is yours. 1 second here, and we'll be back in a bit.
All right. Awesome. Well, and that joke's actually a perfect intro because when that meat comes back to Earth, you get a meteorite. And that's what this first slide is about. So one of the things that I've studied in my career is meteorites, and meteorites are rocks from outer space that hit Earth, and then we get to study them. So there's a picture of one in the upper right there. That's kind of what it looks like if you find one on the ground. It's going to look like the outside portions of it. There's a strip in the middle that's kind of removed there, and that shows you what the innards look like. And then if you were to slice it open and stick it under a microscope, an imaging microscope like the one that you can see in the bottom left corner, then you can make pictures like the picture on the left there. So on the far left, the different colors are different chemicals that are in the meteorites. And then you can also kind of see how much the different atoms that are in the meteorite weigh. And if they weigh more, then they're brighter. They're white, and if they weigh less, then they're darker. And so that helps us look at the chemistry of the meteorites, and that tells us about different chemical environments in the solar system. And then on the bottom right, you can see a picture of the Allende meteorite. So Allende fell in Mexico in 1969, and it was used kind of as a test study before the lunar rocks were brought back in Apollo. And one of the really cool things about Allende is that it has a lot of those little fluffy white things in it that you see. They're called CAIs, calcium aluminum rich inclusions. But what's really cool about the CAIs is that they're the very first solids that formed in our solar system. So they're older than Earth is, and they are 4.568 billion years old. And we know that by measuring lead in those CAIs. So that's one of the really cool things about meteorites, is that they are from the time when planets were forming, and we think that they're kind of remnants of planet formation. So when we study them, we can learn all about what chemistry was like when the solar system was first forming, and that kind of tells us why planets form the way that they do, and why the planets in our solar system are different from each other. So that's pretty cool. Next slide. Okay, so speaking of very old things in our solar system, so meteorites come from asteroids, and asteroids are small bodies in the solar system, much smaller than planets are. And comets are other small bodies in our solar system, and they are also very, very old. And so we think that Comets are also kind of remnants of planet formation, or some of the building blocks that were used to build the planets. But they have more ice, more water, more gases. So a lot of the things that are gas phase at warmer temperatures, where asteroids formed, they turn into ices at colder temperatures where the comets formed. And so different proportions of these rocky materials and icy materials are put together to build the planets. And the outer solar system has more of the icy material in it. So when we study comets, we're partially studying where Earth's atmosphere came from. And then we're also kind of studying how the outer solar system got formed. So another project that I'd worked on was looking at Titan, which is a moon of Saturn. There's a picture of it on the upper right there. You can see Saturn's rings, and then Titan behind it. And one of the really cool things about Titan is that it's got this really thick atmosphere. It's even thicker than Earth's atmosphere, and it's the only moon in our solar system that has an atmosphere. And so we want to know why it has an atmosphere and where it came from, and what does that tell us about Earth's atmosphere. And so one of the projects that I've worked on and am working on is kind of looking at whether materials from comets could have played a role in forming Titan's atmosphere. And so comets have some icy material, but then they also have some material that's kind of like charcoal. It's got a lot of carbon in it, and also a lot of nitrogen. And so one idea that we're testing is underneath of Titan's surface, there are different layers, kind of like how Earth has different layers: core, mantle, and crust. So in Titan's core, if you heat this charcoal material, you can produce gases, and then maybe those gases come out through the water and ice layers of Titan and contribute to the atmosphere. And in the middle there, you can see there's a probe that's actually landed on Titan. There's some really cool videos online of it descending through Titan's atmosphere, so go check that out sometime. But this is a picture that it took when it landed on Titan. So that's pretty exciting. Next slide, please. Okay, so another thing that I've worked on is studying the chemistry of Saturn's rings. So the Cassini mission was active at Saturn from 2004 until 2017. And right at the very end there in 2017, the spacecraft started to do some orbits like you see in the upper right there. The blue lines there show the path that the spacecraft went on. And during that time, it was actually passing between Saturn and its rings. And it took several passes between Saturn and its rings. And that was the closest that the spacecraft ever got to Saturn's rings during its 13-year mission. And the team noticed when we were flying between Saturn and the rings that there was a lot of material, a lot of chemicals in that space in between that we didn't expect. So we were expecting to see hydrogen and helium, which are the main chemical compounds in Saturn's atmosphere. And instead we measured things like water and methane. And it turns out that that was coming from the rings, and the rings are falling into Saturn's atmosphere. The very innermost ring is falling in, and it's falling in really fast, or it was during that time period when the spacecraft was flying like that. So we don't know how often it's falling in that fast. If it's always falling that fast, then that probably means that the rings are actually really young. And they didn't form when planets formed. They formed maybe like when the dinosaurs were around here on Earth. So that's kind of a fun thing to think about is if dinosaurs had a telescope and they looked at Saturn, would it have a ring or not? And we don't quite know the answer yet because we don't know if the rings are always falling in at the same rate or not, but maybe they wouldn't have seen rings if they had a telescope. So dinosaurs and telescopes. Next slide, please. Okay, so the project that I'm really actively involved in, oops, back one slide, please. Okay, my main project right now, I'm working on an instrument that's going to go to Jupiter's moon, Europa. So that's an artist's sketch on the left-hand side of this mission, the Europa Clipper mission, and it's flying over a drawing of Europa's surface. And one of the cool things about Europa is that we are pretty confident that there is a liquid water ocean underneath its icy crust. And so this mission, the Europa Clipper mission, its main goal is to figure out if Europa is habitable. So could something live there or not? So we're going to go measure and see. We know that there's liquid water there in the ocean, but we don't know if any of that liquid water ever makes it up to the surface at all. And we're going to go look for the chemicals that are used in life and see if there's energy there or not. So one of the instruments that we're sending for that is called a mass spectrometer. And it's kind of like a sniffer. We're going to go sniff the atmosphere around Europa. And then we're going to learn what it's made out of. And that's going to help us answer those questions about habitability. So you can see a picture of a mass spectrometer like the one that we're going to send to Europa in the upper right there. And then in the lower right there, that's a photo from September of me and my coworker testing this instrument. You can see some of the data on the computer screen there. So we got to operate the exact instrument that's going to go fly around Europa. It's going to launch in October 2024. So that's been pretty cool and exciting to operate something that's going to Jupiter. Yeah, those are the slides that I have to share today about the work that I do as a planetary scientist.
Awesome. Well, I'm still stuck on this Saturn's rings that are falling into the atmosphere. And I'm guessing whenever you went or when you sent this probe there, that wasn't something you expected. So you had some like research questions, and then this was like an unexpected result. So can you talk a little bit more about that? Because I'm just like, what?
Yeah, no, I think, so I started to get involved with that project really heavily just a few weeks before those data were collected. And I sat down with the group leader and we said, okay, we're going to look at hydrogen and helium at Saturn, and we're going to try and figure out how much helium there is, because that's going to tell us about planet formation. And that's what this data set is going to have. And we said, okay, great, that's the plan. And then, yeah, weeks later, the data started to come in, and we said, well, what is all this stuff in the data? Why do we see water? Why do we see methane? And at first it was just kind of a big question mark. And then as the spacecraft started to get closer and closer to Saturn, we could kind of track and see that there were more of those compounds when we were closer to the rings and less when we were closer to Saturn. And so it was like like a treasure hunt trying to piece together where these unexpected results were coming from and how do we interpret them and why is it happening. And there's still some questions that remain. At the very end, the spacecraft plunged into Saturn's atmosphere, and that's how we disposed of it. And so we aren't getting any more new data now. But it's a pretty intriguing trail of clues. And one of the possible results is that, yeah, the rings are pretty young.
And I think that's such a cool insight to how science really works, because students in the classroom often have the scientific method and you have a hypothesis and then yes or no, is my hypothesis correct? But it's often not that straightforward, and it seems like a really messy process because you don't exactly know what you even want to ask, and you're kind of collecting data and see where it leads you. So I hope that gives students like another view of science that makes it a little bit more exciting. Like there's no answer in the back of the book. Like we don't know. Like that's the whole point, is to figure out what we don't know.
Yeah, definitely. It's really exciting. It's very dynamic.
Yeah. Okay, so let me get to the questions from the students. So Aspen, if you want to ask our first question.
Sure. So this is from Space Rangers in New York. How does chemistry help space exploration?
Yeah, great question. So I talked a little bit about this on my slides that I shared, but chemistry kind of helps us track different processes for planet formation, for example. So we can figure out if we want to learn why do some planets have a lot of water and why do other planets not have a lot of water. Then we need to go measure the chemistry of different objects. We need to know how much water is at each of those planets. So that's, measuring the chemistry of those planets to answer those questions. And then that tells us, about whether life could have originated at those planets, or could it support human life in the future if we we're going to build a base or a habitat there. What do we need to bring with us? So it's important for a lot of those reasons. It helps us figure out how planets evolve and what parts of their environments are interacting and how they're changing.
And what motivated you to go into like chemistry specifically, like within planetary science?
So my undergraduate degree was in just straight up chemistry. And I guess I originally started out, I wanted to be a marine biologist. And then I had a professor who was just really great. And he was in chemistry. And I think maybe one of the moments when I decided, I want to switch over, he was talking about colors and the way that we perceive colors of different objects and how that's related to the way that the molecules in them are arranged. And I just thought that was like the coolest insight, that we're like little human instruments and we're measuring chemistry all the time and we don't even know it. So yeah.
Very cool. Thanks.
And this is a follow-up to what you were just talking about. Did Mars ever have water? 3 Martians from New Jersey.
Yeah, great question. Yes, Mars does have water, and it has water today. So there's ongoing research to kind of figure out where that water is and how accessible it is. So we know that there's water beneath the surface of Mars. There's also water in the polar caps. So if you look at a picture of Mars, a lot of times you'll see white polar caps on it. And a lot of that material is water. And then there's kind of an ongoing debate in planetary science about whether that water is ever at the surface and briefly liquid, or if it's always kind of frozen beneath the surface. And so if we look at surface features on Mars, sometimes you see changes in the surface that some researchers hypothesize are caused by flowing of water, but that's an area of ongoing research. So we don't know yet if that hypothesis is correct or not.
All right. Is there anything that you wish someone had told you when you were younger that you can tell us, from Galaxy Invaders in Texas?
Yeah.
No pressure.
That's right. Yeah. Timeless wisdom on the spot. I think maybe what it's taken me time to learn is that not feeling like you know a lot about something is an opportunity, and not something that's scary or intimidating, right? So if there's an area of science or anywhere in your life really, and you feel like you don't understand it very much, that's okay, because everyone's at some point in their life where they don't understand it, and you just go learn about it, and maybe you'll find something really cool, and it's an opportunity.
Oh, yeah, I like that.
And I think it's important to emphasize learning outside the classroom too. You don't have to wait for your teacher to talk about it in class. You can find books or websites or stuff to continue learning what you're interested in.
Absolutely, yeah.
Yeah, or through Space Club and our experts. And so now we have a question from Illinois. Lunar ladies want to know, what is the craziest thing you've come across during your research? And you just shared some really cool stuff. You have any other crazy things?
I guess I didn't talk too much on the meteorite slide, but one of the really cool things about those meteorites, so there were those kind of round or circular or oval shapes in the meteorites, right? And the reason that they have that shape, because if you've ever seen an astronaut on the International Space Station drink water or Tang, maybe you noticed that it forms these bubbles before they eat it, right? So it's the surface tension of the liquid. And so the reason that there are those round shapes in the meteorites is because those components used to be liquids. So they were like little liquid blobs of lava floating around in space before they got pulled together into the rock. So I didn't discover that, but one thing that I did find in the meteorites that I was studying in grad school was that some of those have sulfur chemistry instead of silicon chemistry. So that's pretty cool. Or I thought it was.
Yeah, that's really cool. Yeah. That's awesome. All right. So one of the questions, this was for mission 2, we asked, would you travel to the moon? And so I picked out some of the student responses. Dr. Miller, would you travel to the moon?
Absolutely. In a heartbeat.
All right. So this is Galaxy Wars from New Jersey. Yes, because I want to feel the moon, see the craters, and get samples of it to see what those samples would do on Earth, just like a scientist would. And then we have Hiba from Kuwait. I would love to travel to the moon. I would like to experience moonwalking. I also want to look back at how our planet looks from the moon and discover the unseen part of the moon. Yes. All right, we got one interesting comment though, which was no, we would not go to the moon because it would serve no purpose. And I just was like, you know what? I need to ask our expert her opinion, because I think some of the public says, why do we spend so much money on agencies like NASA that get us to the moon? And now we're talking about going to Mars and all the research that you've done and sending out satellites and probes. What's the point of it all? What do you think?
Yeah, that's a great question. Yeah, and I think for me personally, it's kind of the same as why the arts are important, why it's important to make music or to create paintings or create anything, right? It's like an expression of our humanity, and it's what makes us human to express these ideas and continue to expand what we know and our understanding of where we come from and where we could go in the future. So I think that there are lots of very important problems here on Earth, and it's really good to address those. But I think it's also really important not to lose sight of our humanity and to express that. And one important way to express that is to keep asking and keep finding answers to those questions that people have been asking since forever, right? Like a lot of the research that Galileo was doing back in what was that, probably the 1600s or something. He was asking the same questions, right? They're important questions. So that's my like philosophical reason why I think it's important to do these things and valuable to do these things. And then I think there's also the practical side of it, which is that that investing in space exploration it pays dividends in a more concrete way also. And some of that is inspiring folks to do research that's applied here on Earth, and then some of it is directly applying the results to create new technologies here on Earth. So I think this is a list from Jet Propulsion Laboratory of ways that space exploration have benefited the technologies that we use here on Earth all the time. Landmine removal, that's pretty important. Athletic shoes, those are
shoes. That's kind of cool. Some
yeah.
space construction technology.
Yeah. So I guess that's my answer. What do y'all think?
I mean, I don't know if I could say it any better. I think it's part curiosity. We're always seeking to explore and learn, and it's just an innate thing that humans have, and it keeps us dreaming and motivated. When the first humans landed on the moon, that was just a moment of humanity, that people that were then watching that as kids wanted to be scientists and engineers and you know, dream big. And I feel like space is something that brings us all together. There's a lot of politics and kind of nasty stuff that happens in the world, and space is just this amazing place. Like, we have the International Space Station, we can all work together and live together, and that keeps me excited about being a human. That's what I think.
Yeah, I think it also pushes us to be better too, because like, you know, we go to the moon and then what's next? Mars, and that brings so much more innovation. And you saw that innovation that, you know, NASA products turn into, you know, household items, and you wouldn't even have, you know, phone cameras and be able to go on your social media apps without NASA. So it's, you know, I think NASA and space exploration is like in our lives every day, even if we don't realize it.
Everybody, and thank you, Dr. Miller, for joining us today. And we'll see everyone next week.